In this section, we want to talk about the polar form of complex numbers. In previous section, we talked about complex number, and we said that we show complex numbers in forms of I, and any complex number can be written as a plus bi, which a is the real part and the b is the imaginary part of the complex number. So every complex number has two parts, real and imaginary. And if we want to show that point on the coordinate plane, it has to be on a complex plane, which the x-axis in the complex plane is the real axis, and the y-axis is called imaginary axis. And when we want to show the point, a, which is the real part, is on the real axis, b, which is the imaginary part, is on the imaginary axis, and then we can find the point of a plus bi. Let's look at an example. We want to plot the complex number in the complex plane. Okay, so in this complex number, a, or the real part, is 2, b, or the imaginary part, is 3. So we will have a complex plane, which the x-axis is the real axis, y-axis is imaginary. Find 2 on the real axis or the x-axis, 3 on the y-axis or the imaginary axis, and then we have the point. It's easy. Next example, again, in this complex number, a is -3, b is -5, and we need to show -3 on the x-axis, -5 on the y-axis, so we get a point on the third quadrant for sure, because both of the x and y, or a and b, are negative. And if we want to show this complex number, as you see, this complex number do not include any I, doesn't have any imaginary part. So, which means the b, or the imaginary unit, is 0. And -4 is the a, or the real part. So a is -4, b is 0. So we have a point of -4 and 0. And for sure, the point is on the x-axis or on the real axis. Now, how we can find an absolute value of a complex number? Absolute value of a complex number, when we have a point, absolute value means the distance from the point to the origin, which means the distance of this line. And since we can create a right triangle, which this side is B, this side is A, the distance, or the absolute value, is exactly the hypotenuse of that right triangle. And we know how to find the hypotenuse by just a square root of a square plus b square. We use the Pythagorean theorem to find the distance of the hypotenuse. So every time they ask us to find the absolute value of a complex number, or the distance from the point on the complex plane to the origin, we use this rule or this formula. For example, we want to find the absolute value of this complex number. Okay, in this complex number, a is 5 and b is 12. And to find the absolute value, we need the square root of a square plus b square. So 5 squared plus 12 squared. 5 squared is 25, 12 squared is 144, 144 plus 25 is 169, and square root of 169 is 13. So the absolute value of this number, or the distance from this point on the complex plane to the origin, is 13. We also learn how to write a complex number in polar form. So we said that in the polar coordinate or polar grid, we always show the points by using r and theta, which r is the distance from the point to the origin. And we said that the absolute value of any complex number is the distance from the point to the origin. So r, it's exactly the absolute value of the point of the complex number, and theta is the angle that that point is creating by the x-axis. So if I have a point z equal to a plus bi, so the distance from this point to the origin, it's the absolute value of z, which is exactly r. And if we create a right triangle here, this is the b, this is the a, and theta is the angle that created by this line and the x-axis. So to find the data, we just need to find the tangent of the angle, which is opposite over adjacent. So the tangent of the angle is b over a. And if you want to find the angle, you use the tangent inverse key on the calculator. So the tangent inverse of b over a. To find the r, we need to use the formula for finding absolute value. And we also know that since the sine of this angle is opposite over hypotenuse, so the sine is b over r, which means b is always equal to r times sine. And since the cosine of this angle is adjacent over hypotenuse, which is a over r, so if we solve for a should be equal to r times cosine theta. And we talked about all of these formula, the relation between the x and y and r and theta in previous sections. That's exactly the same, but this time instead of using x and y, we use a and b because we show any complex number by a plus bi. Otherwise, the a is exactly the x, b is exactly the y. And to show the point in polar form, we use this rule. So the z is always equal to r times cosine theta plus I sine theta because it's a plus bi. A means r times cosine, b means r times sine. And we call r the modulus, and in polar form is moduli, and theta or the angle theta is called an argument. And the angle is always between 0 to 2 pi in just one rotation of the circle. For example, we have a point, we have a complex number, z equal to -1 minus I root 3. The point is on the complex plane, and we want to write this point in a polar form. Polar form means we need to find r and theta. So first of all, what is a, what is b? So in this complex number, a is -1 and b is -√3. Okay? We can plot the point also because it helps us to know where the point is. When we want to find the angle, we need to know which quadrant the point is or the angle is. Okay? So when we plot the point, since a is negative, b is negative, the point is on the third quadrant. Now we are going to use the formula to find r and theta. To find r, I need to find the absolute value of the point, which is a squared plus b squared, and replace numbers for a and b. And to find theta, I need to use the tangent inverse. So because the tangent of the angle theta, it's b over a. And as you see here, if this is r, and theta is the angle creating by the positive side of the x-axis. That's the theta. So we are looking for r and theta. So to find the r, as I said, we are using the formula for the absolute value. Replace the a by -1, replace the b by -√3. So -1 square is +1. Negative square root of 3 is square, which is negative times negative is positive. A square root times a square root is just 3. And 1 plus 3 is 4. And the absolute and the square root of 4 is 2. We found the r. Now to find the angle, we know that the tangent of the angle should be b over a, which is -√3 over -1. That's exactly positive √3. But we know that the angle is in the third quadrant. Any angle that we find by using this number, it's a reference angle. If my angle is also in the first quadrant, I can use the same angle that I found from the table. But if the angle is in other quadrant, we need to use this answer because I know that the root 3 is the tangent of pi over 3. Okay, but this pi over 3 is a reference angle if the angle is in the first quadrant. But if it's in other quadrant, we need to find the exact angle. And right now, in my picture, the angle is in the third quadrant, and third quadrant means a pi plus the reference angle. If this reference angle is pi over 3, the angle is in the third quadrant, so it's pi plus pi over 3. And if I find the common denominator and add them together, I get 4 pi over 3. So that's why I say the angle is 4 pi over 3. Okay, so make sure always plot the points and see which quadrant the point is, then you can decide what's the angle correctly. And after finding R and theta, now we can rewrite the number in polar form by using this formula, R times cosine theta plus I sine theta. We can multiply R by the two terms, or we can keep it outside the parentheses. It doesn't matter. So R is 2, theta is 4 pi over 3. So now I have that answer in polar form. So this is in complex plane, the point in the complex plane, and now I have in the polar coordinates. So another example, this time we have a point in a polar form and we want to convert it to the complex number or to rectangular form. Okay. So when we have a point in the polar form, that means we have R and theta. Based on the number that I see here, the R is 12 and the theta is pi over 6. But if I want to write the number in a rectangular form or in complex plane, I need A plus BI. That means I need to find A and B. So what formula we can use? We know A is like an X, which is always equal to R cosine theta. B is like the Y, which is always R times sine theta. Now we can replace numbers for R and theta. R is 12, theta is pi over 6. Pi over 6 means 30 degrees, and I know the cosine of 30 degrees is root 3 over 2. And if I simplify 12 by root 3 over 2, I get 6 root 3. Same for the B, 12 times sine pi over 6. The sine of pi over 6 or the sine of 30 degrees is 1/2. And if I simplify, I get 6 times 1, which is 6. Now, after finding A and B, we can write the number in complex form, which is Z equal A plus BI. A is 6 root 3 plus 6I. There's another way to find the number in complex form is just finding the value of this cosine and sine. If you find the cosine of pi over 6, you get root 3 over 2. And sine of pi over 6 is 1/2. And if you distribute the 12, you get exactly this number, even if you don't want to use the formulas. How we can multiply two complex number in polar form? If we have two complex number in polar form, to multiply the two numbers, we just need to multiply the R values. R1 and R2, R sub 1 or R sub 2 means we have two different R. And we need to multiply the R's, but for the data, we just need to add them together. So we will have another complex number in polar form, which the R's are multiplying together, but datas are adding together. So we just need to multiply moduli and add arguments, which is data. Okay, let's look at an example. We have two complex numbers here, Z1 and Z2. And we want to find the product. To find the product, we just need to multiply the R's and add data. So if I multiply r 6 times 5 is 30 and add data values, which is 40 plus 20 is 60. So I will have 6 times 5, the cosine of 60, sine of 60. To divide two complex numbers, to find the quotient of two complex numbers in polar form, we divide r's, we divide the moduli, but subtract data or subtract arguments. For multiplication, we multiply and add. For division, we divide and subtract. So let's look at an example. We have two complex numbers here. We want to find the quotient, or we want to divide these two complex numbers. As I said, we divide r, we subtract data. Divide r means 50 divided by 5, because it says the quotient is z1 over z2. So when it mentioned which one should be on the numerator, so you have to start with that number. So z1 must be on top. So we divide 50 by 5, which gives us 10. And we need to subtract data. 4 pi over 3 minus pi over 3 for both of the sine and cosine. So 50 over 5 is 10. 4 pi over 3 minus 1 pi over 3, which is 3 pi over 3. And if I cancel 3 by 3, I get cosine of pi and sine of pi. And that's the complex number, the result of the quotient. To find the powers of a complex number in polar form, any powers, again, we need to raise r to that power. If it's the second power, we raise r to the second power. If it's the third power, raise it to the third power. But we multiply angles or data by that number. If it's the second power, we multiply angles by 2. If it's the fifth power, multiply angles by 5. So this is how we raise any polar form of a complex number to the powers. Okay? And n can be any power. It depends on the problem. And as you see, raising a polar form is much easier than raising a complex number. Because if you want, for example, if they give you this number and they ask you to find z to the fifth power, you need to multiply these parentheses 5 times and then multiply it together 5 times. And you know how much multiplication we need to do. But if we have that exact number in polar form, we just need to raise the r by that number and then multiply the angles. That's it. That's all we have to do. So sometimes it may be easier, even if you have a number in this form and they ask you to raise it to a power, you change it to polar form and then raise it to that power. For example, I want to find the fifth power of this complex number, and then write the answer in rectangular form of a plus bi. Okay, so for raising this number to the fifth power, I only need to raise r, which is 2 to the fifth power, and multiply the angles by 5. 30 degree times 5 is 150 degree. So we raise 2 to the fifth power and multiply angles by 5. And I know we get 150 degree for angles. Now that's the answer in polar form. If you just need to raise to that power, you can stop here. But if they ask you to write the answer in rectangular form, now you need to convert to the rectangular form by finding the cosine of 150 and the sine of 150. Cosine of 150, you know that the 150 is an angle in the second quadrant. And to find the cosine of 150, if you don't have a table value, you need to find the reference angle. And the reference angle for that angle is this angle, which is 30 degrees. Which means the cosine of 150 is the same as the cosine of 30 degrees. But since the 150 is in the second quadrant and the cosine is negative in the second quadrant, the answer should be negative. So the answer is negative root 3 over 2. So replace the cosine of 150 by negative root 3 over 2. The same for sine, because 30 degree is the reference angle for 150. So the sine of 150, that should be the same as the sine of 30 degree. And the second quadrant, the sign is also positive, and it should be equal to 1/2. Now we distribute 32, simplify 32 by the denominators of 2, and then we get negative 16 root 3 plus 16i. Now I have the answer in rectangular, in complex plane. So far, we learned how to multiply, how to divide, and how to raise a complex number in polar form to any power. Now let's see how we can find roots. If I have a complex number in polar form, and I want to find the nth root of that number, like second root, fifth root, fourth root, 10th root. How do we do that? So we are going to follow one of these formula based on if the angles are in degree or in radian. So first of all, we need to find the nth root of r. But for angle, what do? We add data by 2 pi k over and then divided by n, which k can be any number from 0 to n minus 1. What does it mean? For example, they ask me to find the third root. So third root means k can be only 0, 1, and 2. That's it. That means you write the formula and replace the k by 0, find answer. Replace the k by 1, find answer. Replace the k by 2 and find answer. So you find 3 different roots. If they ask you to find the sixth root, that means you are supposed to replace k by 0, 1, 2, 3, 4, and 5. 1 less than 6. So you have to write this formula 6 times. First replace by k by 0, then replace by 1, by 2, by 3, by 4, and by 5. So you will have 6 different sets of answer. But if the angles are given in radian, use 2 pi k. If it's in degree, put 360k. They are the same. So add your angle by 2 pi k or 360k and then divide it by the n. If it's sixth root, you need to divide by 6. If it's third root, divide it by 3. Now let's look at an example. And this theorem also called the Moivre's theorem, which is one of the important theorem in complex number. Let's look at this example. We want to find all complex fourth root of the number. Okay. When they ask us to find fourth roots, that means k can be 0, 1, 2, and 3. So the angle is given in degree. So I write the formula which is in degree with 360 degree. Then start replacing numbers for k. I replace k by 0. And if I replace k by 0, I get 360 times 0, which is 0. 60 plus 0 is 60. And then divided by 4 because we want to find the fourth root. And 60 divided by 4 is 15 degree. And if you calculate one of these, you have the answer for the other one as well because they are the same. And we also need to find the fourth root of 16, which is 2. So that's my first set of answers for only k equals 0. Now I replace the k by 1. If I replace the k by 1, I get 360 times 1, which is 360, and 360 plus 60, which is 420, and if divided 420 by 4, I get 105. And the fourth root of 16, which is 2 for all of the answers. So that's my second sets of answers. You don't need to find the sine and cosine of 105 unless they ask you to write the answers in rectangular coordinate. Then we replace the k by 2, replace the k by 3. Now we have all sets of all fourth roots. So we have 4 fourth roots. Okay? 4 complex fourth roots. And these are the solutions. If they ask you to find fifth root, you will have 5 answers. If they ask you to find sixth root, you will have 6 answers, 6 different sets of answers. Let's look at this example. We want to use the same theorem to find the answer for 1 plus I to the 4th power and write the answer in rectangular form. Okay, we have a complex number 1 plus I and we want to raise it to the 4th power. Okay, so raise to the 4th power, we have a formula for raising to the power which we learned in this section, but that was when we had the number in polar form. If I don't have a polar form, for finding the answer for this, I need to write the parentheses 4 times and then multiply them together. So you need to multiply the first 2, find the answer, then answer multiply by the 3rd one, then find the answer and multiply it by the 4th one, and then find the final answer. And you know how long does it take that you can find all the answers. Because every time you multiply by a new parenthesis, you will have more terms for multiplying. But I think it should be easier, since I want to use this theorem, it should be easier if I convert this into polar form first. Okay. Then raise to the power. After that, convert it back to the complex. Okay. So just use the polar form, convert to polar, raise to the power, then convert back to the complex number. Just use the polar form to make everything easier for ourselves. So let's do that. If I want to convert to the polar form, so I need to plot the point first. 1 plus I means A is 1 and B is 1 as well. So 1 and 1 means the point is in the first quadrant. So I can find R. So that's 1, 1. So the R is the square root of A squared plus B squared, which is the square root of 1 plus 1, which is 2. And I know the angle is the tangent inverse of B over A, which is the tangent inverse of 1. And I know that 1 is the tangent of pi over 4. Since my angle is in the first quadrant, that's my final answer for data. But if the angle is in the other quadrant, this is your only reference angle. You need to find the angle based on which quadrant your angle is. Sometimes you may need to subtract it from 180 if it's a second quadrant. If it's in the second, subtract it from 180. If it's in the third, add it by 180. If it's in the fourth, subtract it from 360. Okay? Then after finding R and data, we can rewrite the answer in polar form, which is R times cosine of pi over 4 plus I sine pi over 4. Now I have my angle in polar form. After changing to polar form, we can now raise it to power, which is right now it's 4 power. So now I want to raise this number to the 4th power. So write the number cosine of pi over 4 plus I sine pi over 4, and then raise it to the fourth. To raise to the power, we need to raise this number to the power of 4, which means multiply root 2 4 times. I know root 2 times root 2 is just 2, root 2 times root 2 is just 2, and 2 times 2 is 4. And I also need to multiply each angles by 4. So I need to multiply angles by 4. So 4 and 4 cancel each other. So we just have the cosine of pi plus I sine of pi. Now you raised it to the power of 4 in polar form. Step 2. Now in step 3, I'm going to back to the complex number, convert this polar number into the complex again by finding the sine and cosine of pi. So what's the cosine of pi? It's -1. What's the sine of pi, which is 0? And if I distribute, this is a 0. So the final answer is just -4. So that's it. If this number is z equal to this number, if z actually is equal to 1 plus I, z to the fourth power is -4. So instead of multiplying those 4 parentheses together 4 times, multiply them together, add or subtract, combine like terms, we can just use this rule, converting to polar, and then raise it to the power, because raising to the power in polar form is much easier than rectangular form.